Hello again. This is a follow-up to the demo I gave last week where I demoed the type checker widget which ran rustc through to the type inference stage and then printed out the type of a selected item. So I've made a few improvements I'm going to demonstrate now. If you remember last time, the issues were there was an issue of performance, and then there was also the problem of type checking a crate that wouldn't compile properly. So I'll demo that first, I think. So if we create a function here and we do this. Now, the first issue was that at the moment, this vector, for example, hasn't had its types fully specified because you haven't put anything in there, so it doesn't know what it's a vector of. But we can still pull out the type you see here, and there's a type variable in the bottom. I'm doing that by basically I've patched the type check module to allow access to the internal tables after the type check has run. So even though the type check fails, you still have access to the state of the type variables, and that's really useful. Racer could use this, for example, to deduce that this is a vector and then go away and find the methods to that. It also illustrates how cool rustc is at inferring types. So, for example, if we do something like this here, this is still a vector of type variable. But if we do something like this and add a 3 to it, now it has to be a vector of I32s, and you'll see here I32. Or if we look at this V here, it's an I32. So that's pretty cool. It also means that you can get away with parsing code that's a lot less complete than last time. So I'm going to stick a V here, and this will still parse perfectly well. There we go. Okay, and so the other problem was one of performance. Now I haven't really solved it that well, but you remember that it took something of the order of 10 seconds to do a type check on a large module, on a large crate. So if I pull up a crate from the Rust source, let's see, so lib rustc type check, I think we used last time, something from here. So this time if I highlight something, let's do that. You see it comes back, it's almost sub-second. If I've got the CPU jacked up to the max, then this is almost sub-second. So I mentioned in the email that really the kind of bar for doing interactive suggestions in an editor is kind of 100 millis, that sort of time frame. So I've still got quite a lot of work to do. So in order to get this sped up, basically the approach I've taken is when we supply rustc with the code, we first pre-process it so that we basically look for the function that we're interested in using the coordinates that Emacs has passed, and then we process the source code that we pass into rustc and remove the contents of all of the functions which aren't the function you're interested in. And that's still fine because the Rust has that nice feature where if you have the function signatures, then you don't need to know anything about the bodies, and so we do that. So in this main function here, I don't know how easy it will be to see, but basically the type check phase here goes all the way through, and then I take over. Actually, sorry. First of all, I've overridden the file loader, which you can just poke in. Here we go. Yeah. So here's the stripped file loader, and that basically masks the source on the way in. So it replaces anything in a function body with spaces and new lines, so that the coordinates still match, but there's nothing in the functions. And then after it's done that, then it replaces the entire body check visitor with one down here, which does not much more than locate the actual body it's interested in. And then I've patched check item body in the type check module to actually return the tables once it's finished doing the type check phase. And I've also patched the erroring so that it just basically ignores the type check errors. I've got them printing to standard out here, but basically we get all the way through and we don't fail if we hit a type check error. And then that's it. And then we use that table to look up the state. And that's the lot. Okay, cheers.